Welcome back. Now we'll be looking at the rules of derivation for second degree functions and other polynomials, but for the moment we'll keep to just second degree functions. All right, let's pull up a second degree function and just take a look at it. Now we're rather used to this form now, and when I was describing first the non-mathematical description of how the derivative looks, I said you could choose any point you would like on the graph and draw a tangent to it. And for each place, you'll get a different line. I'm making them very short because you know my lines by now. They're never straight. Um, Regardless of the place, you can get all kinds of neat little tangent lines, and each tangent line will have a slope. Now, let's take a look at the derivative, and here we followed the rules. We first had this function, and then we took the derivative. So we say f of x equals x squared plus 3x plus 2. We take the derivative and we get a new function, f prime of x. And as you can see, it is a linear function. Now this linear function is the yellow one here. The purple one is the father, the original function. So we have the the adult here and then the child there. So one way to look at it anyway. Now I want to show you how this runs together when we try to look at the tangent line for a particular place. All right, so here I've created a simple function because it's easier than to see on the graph, but it works for all. It's just this is something that is very easy to look at. So, okay, the red one is your standard f of x equals x squared. So it's a big red smile. Then the derivative is going to be this one, and that's the yellow line. And as you can see, it is a positive line. It has a slope. Here's the slope right there, 2x. And let's take a look now at the next page where I have put in a tangent line for a particular spot. And I would be drawing a tangent line right there. Well, it's better to let the machine do it. Here we go. Okay. Now what this means is we're letting x be 1, and then on the original function that gives a value of 1 because here's the function. We'll put in an f of 1 equals, of course, x squared, but then x is 1, so that gives you 1 squared, and 1 squared is 1. Okay, so the value of the original function, in other words, when f of x has a value of 1, that's the place we're going to look for our tangent line, right there. Okay, and you can see the purple line is the tangent line. It does kind of look a little blurred in there, but it's supposed to only touch the function at one spot. It's just a little hard to draw when pixels are as big as they are. All right, so let's see what is happening here. What happens to this when we say that f prime is going to be analyzed at 1? Let's see what happens. We get 2 times 1, which is 2. Now, if you were to measure the slope of this purple line here, try to find the slope of that by doing your delta y and your delta x. Now I've kind of made a mess down there. Let me clean it up. Okay. You can even read it off the graph. You can say, okay, I can see here the tangent crosses right there. And of course it meets right there, which has a value of 1. So the base of this triangle is 0.5. That's going to be our delta x. The height of it is 1. Now what is 1 divided by 0.5? That is 2. That's exactly what we expected from this yellow line here. Now we can't see this yellow line continuing. It keeps going up, but I have limited resolution to work with. You would see that if you plop in the x that you're trying to look at, you're going to get one value for the original function, another value for the derivative function, and that will tell you the k value of the tangent line. So it's kind of multiple things. This original yellow line here, and now it's getting pretty messy. The original yellow line is going to give you the values of every derivative that you could want for the function. You may wish to have a value perhaps over here. And you can't read the value from the graph, but if you could get a graph the size of a blackboard, then you could just graphically go read it off. We expect the tangent to have a negative value because the tangent line is pointing, reading left to right, it's pointing down. Just like here, the tangent line is pointing up. Only there, when the tangent is completely flat, do you get a zero value. So a tangent can only be plus, minus, or zero. Those are the only possibilities. If there's a tangent, it's only plus, minus, or zero. And so if we always start off with our first, the Father, the Son, and I'm not going to say the Holy Ghost. I'm just going to say the tangent line. Okay, bad joke. Still, I hope that helps. We'll be doing a lot more on the board, and I'll be making some more of these for you later, because this is the first time we've tried to apply the rules and look at a graphic representation of these. So let's work on a few, and we'll have some fun and see if we can make these rules stick. Okay, thanks. Bye.